again to the project Amor, ICME Awardis multimedia online resources. In this module, I continue pondering on the main characteristics of activities recognized as mathematical. Just to remind you, in the previous modules, I introduced the idea of looking at mathematics as a kind of communicational activity, a discourse in which we construct theories or simply tell stories on mathematical objects. Discourses, it was said, are made distinct by 4 characteristics that may differ from one type of communicational activity to another. They are keywords, visual mediators, endorsed narratives, and rouitnes. In the last module, devoted to mathematical objects, we discussed the first 2 features, words and visual mediators, 2 types of signifiers that we combine together while constructing mathematical objects. In this module, I will focus on the other signature characteristic of mathematical discourse, the rouitnes. I will begin with explaining the idea of routine, and will then present a few facts about rouitnes that can be derived either directly from this commognitive definition or from current research on learning, and especially those from the cutting-edge neuroscience. So let me begin from the beginning. The theme of rouitnes enters the scene when you consider the phenomenon you are so familiar with, you rarely give it any thought. In most familiar life situations, you know what to do. You are able to act in an immediate, instinctive manner. Whether you are bumping into a friend in the street, are in the midst of shopping, or are standing at the board trying to solve a mathematical problem, you know what to do without being told and without deliberation. Of course, you may have difficulty solving a given mathematical problem, but in most cases, you do know more or less what you are expected to do and what kind of action would count as appropriate. And now the question is, where does your ability to decide effortlessly about what to do come from? Let me repeat, when you need to act, what is it that makes you able to decide what to do? A moment of thought, and we realize that the source of most our action is our experience. It is the action that you or somebody else performed in the past in a similar situation that you are likely to replicate now. And to say it in more detail, when you find yourself in a situation in which you feel obliged to act, you tend to recall a past situation that seems to you sufficiently similar to the present one to justify doing now what was done then, whether by yourself or by somebody else. For brevity, let me replace the words in yellow on the left with the brief task situation, or TS for short. And let me substitute this long yellow phrase on the right with just one short word, a precedent. The elaborate initial sentence is now much clearer. When you find yourself in a task situation, you tend to recall a precedent. This means that your past experience is responsible for your future ways of acting. Indeed, according to neuroscientists, the microstructure of our brains is shaped by what is happening to us, and through this structure, it impacts our future actions. And here is my first conclusion. All you do in an immediate, competent way involves replications of your own or somebody else's past actions. Neuroscientists speak here about prediction and simulation. Your brain uses some features of the situation in which you are now to identify a past task situation that appears to you similar to the current one. Predicting that what will happen next will also be similar to what happened then, it prepares you for repeating the precedent action. It simulates the bodily, mental, and emotional state in which you were at that time. This, according to neuroscience, is the basic mechanism behind our overpowering propensity for repeating the past actions, our past actions. An important conclusion follows from here. The repetitions of necessity create patterns of action. These are those patterns of action that I will call routines. Routine, the pattern, can be described as composed of two components. First, there is the task, all the elements of the precedent event that you wish to preserve, to return to now. Then there is the procedure, something that was done in the past and now is deemed as helpful also in executing the present task. In simpler words, the task is something that must happen as the result of the routine performance, whereas the procedure answers the question of how it will happen. In searching for answers, we draw on what we deem as precedents of the current task situation. Of course, since the present task situation, although similar to the precedent one, is still different, our performance and its results will differ from the previous ones in some respects. It is thus important to remember that both the task and the procedure are general descriptions that can be used in a range of situations, just like computer algorithm may be used with a range of inputs. They can be seen as sets of meta rules or general principles for how to act in a given type of task situation. It is because of these routines defining meta rules that I describe discourse as rules-governed activity. And one final remark, the task and the procedure are products of individual interpretations of a given task situation. And as such, they depend on both the situation and the interpreter. In other words, the routine you use in a given task situation is your personal interpretation of the situation. Somebody else could deduce a different task and perform a different procedure in the same task situation. If I will nevertheless sometimes associate a task with a procedure without identifying either the task situation or the interpreter, the intention will be to say that this is a canonic pairing, one that expert performers would offer. I will elaborate on this issue as we go. It is now time to show some examples of routines. My first illustration is a routine for the task of adding two fractions, that is, of finding a fraction s such the narrative s equals a over b plus c over d can be endorsed. One possible procedure for implementing this task can be presented as the following sequence of commands. First, check whether the denominators of the two fractions are equal. If they are, the s is equal to the fraction with this denominator and with the nominator equal to the sum of the nominators, a plus c. If b and d are not equal, we find w, their least common multiple, also known as the lowest common denominator. We then expand each of the original fractions to a fraction whose denominator is W. We are now back to the former case, the case of the sum of two fractions with the same denominator. Of course, we could also use a slightly different procedure. This is just one possibility. The important property of this routine is that it is algorithmic. It defines the sequence of steps in a unique way, making sure that two people who implement this routine for the same pair of specific fractions, A over B and C over D, will end up with the same endorsed narrative about S, unless, of course, they make a mistake on the way. Yet, most routines that we perform in our lives, including many in mathematics, are non-deterministic. They increase chances for a successful performance of the task, but they do not ensure it. We often refer to them as heuristics. Among those heuristic routines are those of proving, of showing endorsability of mathematical narratives. The most general heuristic for mathematical proving is more of a filter for what can count as a proper procedure than it is an actual method that can be trusted to result in a proof. Having said all this, I may now start discussing some general facts about routines. The first property to mention is that routines are recursive constructs. Each of them is built from parts that are routines in themselves, possibly useful as building blocks for other compound routines. In other words, routine may be imagined as a box composed of smaller boxes. Let us take another look at the routine for adding fractions. Note that every element of this procedure, finding the least common denominator, expanding a fraction, is a routine in itself, a routine in itself. Also, the component routines can often be decomposed into even more basic routines. For instance, both finding the lowest common denominator and expanding a fraction involve routines for basic arithmetic operations of adding, dividing, and multiplying. Moving in the opposite direction, we now notice that the routine of adding fractions, when taken as a whole, can become a subroutine of many other routines, for instance, of those of calculating an area of geometric figure or of establishing probabilities. Now, let me note an important entailment of the recursivity and of the fact that every routine may be a part of another one. All the routines of the given discourse are interconnected. When taken together, they constitute a tightly knit network, not unlike that of physical routes that may lead us from one place to another. This metaphor is also reflective of the fact that routines can be seen as interlaced neuronal connections or sequences of synapses that our experience has sculpted into our brains. Because of this structure, the collection of routines within a given discourse has the property called degeneracy. Just as any city destination may be reached through different routes, so can any task be performed with the help of many different routines. Perhaps the similarity between the words routine and route is not purely coincidental. The name degeneracy that I gave to this property is borrowed from neuroscience, where it came from biology. In neuroscience, it refers to an analogous property of the network of neural connections. And now, yet another property of routines. They are situated. This feature expresses itself in certain constraints on our actual use of routines, and more specifically, on the cross-discursive application of routines. Let me explain. We recruit the routines we have learned in different circumstances. Some of these applications more obvious and immediate, and some much less so. The fact that we use mathematical routines during mathematical lessons is no surprise. In school, you are required to practice these routines rather than to apply them in performance of other, not necessarily mathematical activities. It is this later use that I call cross-discursive, because here, mathematical routines are usually incorporated into other non-mathematical kinds of communication, such as the colloquial discourse of buying and selling, or the discourse of self-care. And now, before I continue, let me ask you, in your daily life, how often do you really have recourse to mathematics you have learned in school? Well, let me guess. You probably go truly mathematical only very occasionally, if at all. If this is your conclusion, you are not alone. Multiple research studies have shown with surprising consistency that even those of us who are well-versed in mathematical discourse do not often utilize it in practical task situations. Here is an example of one such study. In this project, the American researcher Jean Lavie followed school graduates of different ages and different professions, and she did it throughout their daily lives. She observed them, among others, as they were shopping in supermarkets. The participants proved impressively skillful in deciding about best buys and in making beneficial choices of groceries. In all this, however, they utilized procedures that had little to do with school mathematics. Later, when tested for their ability to use the relevant mathematical procedures in pen and paper school-like assignments, the participants demonstrated a reasonable proficiency, although admittedly, their performance was much less impressive. Researchers summarized this and similar findings collected in different settings all over the world, claiming that knowing, and not just learning, is inextricably situated in the physical and social context of its acquisition and use. By situatedness of learning, they meant that we apply what we have learned only in situations closely similar to the one in which we first learned it. The similar here means that the current task situation is close to the one in which a routine was first learned, with the similarity judged by such aspects as the situation's physical constituents, its objects and participants, its history, and in result, the discourse to which we usually turn when thinking about it. As could be seen from the examples just given, the situatedness of routines expresses itself in two tightly intercorrelated phenomena. First, even those among us who can skillfully participate in school mathematical discourse rarely recruit mathematical routines in practical task situations in which it could be helpful. In out-of-school settings, we seem mostly oblivious to mathematical routines and to their potential. Second, if we are still able to circumvent mathematical routines in many practical situations, this is because for frequently recurring task situations, we develop idiosyncratic, unmediated routines. These routines are grounded in direct manipulations of the objects we usually find in these situations. Both our obliviousness to cross-discursive options and our tendency to circumvent math-mediated routines can now be summarized as manifestations of our being quite resistant to the option of cross-discursivity. We rarely reach from our current discourse to discourses on other types of objects. For instance, from the discourse on physical objects that you buy in supermarket to the discourse on numbers. What are the sources of this discursive stagnation and thus of the situatedness of routines? To answer this question, I invite you to think about how you recruit a specific helpful routine when necessary. The fact that in most situations you do it without a visible effort and in practically no time makes this question particularly puzzling. Okay, let me present one plausible scenario for how it happens. It is inspired by what can be learned from the most recent developments in cognitive neuroscience. Let me remind that your first step in a task situation is finding a precedent, past task situation similar enough to the present one to justify repeating now what was done then. Obviously, you cannot search for the precedent through all your past experiences. This would be impractical. Fortunately, your brain automatically restricts your precedent search space, or PSS for short, and in a rather drastic way. Indeed, upon being faced with a certain task situation, you also automatically enter a certain discourse. You choose the discourse in which all your thinking in this situation will be done from now on. For instance, during mathematics lesson, most people would search for a precedent and thus a routine in the discourse used during the most recent mathematics lesson. Once your discourse is in place, your current PSS will be delineated by that discourse. You will search precedents only among past task situations in which this discourse was used. The routine that you will eventually use will thus also come from that discourse. With the help of the already mentioned neuroscientific notion of simulation, I can now tell a hypothetical but highly plausible story of your spontaneous and mostly unconscious selection of your thinking cup, of the discourse you will be using while dealing with the task situation you just entered. Upon facing any such situation, you automatically recognize its elements, noticing mainly those aspects that seem to you most useful. These elements, objects, persons, etc., are physical components of what you see and hear. Recognizing an element means recalling the category to which it belongs. The recollection brings to your mind or activates in your brain the experiences you had in past situations that involve the same elements or thus elements belonging to the same category. Once this happens, your brain starts functioning as if you actually were in this past situation. It arranges a simulation of the physical, mental, and emotional state in which you were at that time, as if it was preparing you for the recurrence of what happened to you then. In cognitive neuroscience, and more specifically, in the psychology of grounded cognition, this recurring sequence of events is known as the situated action cycle. The simulation includes also, maybe even in the first place, your return to the precedent discourse. This cycle repeats itself whenever you enter a task situation of a given type, each time reinforcing the connection between the situation and the discourse. You become the captive of this particular discourse, and it is now rather unlikely that you would venture beyond it, even if it does not provide you with a routine for the current task situation. Thus, the cyclic mechanism of situated action seems to be the reason behind the phenomenon of discursive stagnation. As I already said, once your precedent search space is delineated and your discourse is in place, you can proceed and perform the second step. Choose the precedent. With its help, you will be able to interpret the task situation and to tell what your task is. Aware of the task, you will search your current discourse for the matching routine. The mechanism of situated action, therefore, accounts for your obliviousness to cross-discursive options. Discursive stagnation is certainly also a part of an explanation for the second phenomenon. Indeed, it is now clear why, in order to deal with frequently encountered practical situations, you tend to invent your own unmediated, domain-specific routine rather than utilizing ready-made, much more general mathematical routines. Let me now note that the unmediated shortcuts that we invent strike back and diminish the chances for cross-discursive solutions even further. Imagine yourself in a task situation, especially in one that forces you to act on the spot. Here, you will probably be guided by the law of minimizing effort that has been presented as follows by the Nobel Prize-winning psychologist Daniel Kahneman. If there are several ways of achieving the same goal, we tend to opt for the least demanding course of action. Just like a drop of water follows the path of the least resistance, so do you choose unmediated routines, which are obviously thriftier than their mediated alternatives. Being a powerful precedent for future action, this unmediated thrifty shortcut, once constructed, is going to be used most often. Soon, like a frequently traveled route, it will become the main road. With time, it will be the one that would offer itself to you automatically, whereas all the alternatives will be pushed aside, maybe even forgotten altogether. All this certainly reinforces discursive stagnation. To sum up in a metaphorical way, your present discourse delineates your current world, and you remain oblivious to other discourses and to the possibilities they offer. But wait, all this implies that if you want to get out of your present discourse, you only have this very discourse in which to think about how to do this. You can only get out your discourse with the help of this very discourse. The task may appear almost as unlikely as an attempt to lift yourself by pulling your own bootstraps. Well, does it mean that we are doomed to always acting in the same routinized way? That it is beyond us to deal with familiar situations in unfamiliar ways? That there is little space in our lives for innovation and creativity? Does it all mean that we are doomed to always deal with this in the same routinized ways? No, routines are not the opposite of creativity. This indeed is the last, but not least message of this module on routines. On the contrary, our existing routines are the material of which our new creations are made. To use a metaphor, we build our actions from available routines, just like architects build their original buildings, such as this one, this, and this, from building blocks available in the market. In mathematics, like in architecture, It is the novelty in the way we use the existing elements that is the measure of creativity. And returning to the previous metaphor, that of roots, having a rich system of routines, like having a well-developed network of roots, is the condition for creativity. Our inventive spirit will express itself in choosing itineraries that we have not considered in a given context so far. Particularly creative are those choices that make us travel through strange places never before regarded as relevant to our current journey, to our current task. But note that in every case, we build on the existing routines, except that we combine them differently. The newly constructed itineraries, if successful, will be traveled time and again and will thus solidify into new routines. In short, we are creative thanks to our routines, not in spite of them. To learn how the new may be created from the old, and in particular, how the now canonic mathematical routines first came into being, please proceed now to Module 7 of the unit on commognition, devoted to the historical development of mathematical discourse. Thank you.